This video is brought to you by our amazing supporters over at Patreon. Hey everyone, it's Ben from Board to Bits, and in this video we're going to be implementing one more extension of our Flocks functionality, which is the ability to avoid obstacles in our scene. So to start, we're going to create an obstacle. I'm going to simply create a new sprite object in our scene, and I'm just going to call this obstacle for clarity's sake. I'm going to just give it the default knob image here, just a simple circle, and I'm going to increase it in size to about 3 by 3 in terms of scale, just so it's a little bit more visible. And I'm going to move its Z position to 1, just 1 on the Z axis, so that our agents will actually appear to be going over it if they do pass over it. We obviously want them to eventually be avoiding this obstacle, but to start, just so that we're able to see what's going on, we want the obstacle to appear, quote-unquote, under our agents. Okay, so with that, the other thing I need to do to this obstacle is I need to put it onto a physics layer, because this is how we're going to identify that this is an obstacle. So I'm going to go up to layer here and add layer, and then user layer 8, I'm going to add the word obstacle, and then I need to make sure that I go back to my obstacle object and actually place it on that physics layer. Now that that's done, I'm actually going to duplicate this a couple times so that I can make a little bit of a wall with it. So I'll go like this here. Zoom this in a little bit, be a little bit easier. Something like that should be good, just for kind of example purposes. And maybe I'll put one with a little bit of a gap there too. Okay. So with these in place, we now have this sort of wall of obstacles, but right now our flock doesn't know what to do with this. If I hit play, we'll see, as kind of expected, everything just flies right over it. It doesn't interact with it at all. We're not using the physics system, so there's no collisions happening here. They're just completely ignoring this wall. So what we need to do is we need to apply a new filter. This filter is going to look at any transforms around us and say, if you are on the obstacle physics layer, then we will avoid you, or we will take you into account, and then we can apply it to things like our avoidance behavior. So I'm going to go into my filter scripts here. I'm going to create a new C# script, and I'm going to call this physics layer filter. And in here we need to have our create asset menu name. We're going to do flock filter physics layer. We're going to make sure that this inherits from context filter. We're going to delete, start, and update, and we're going to add a public layer mask variable, and I'm just going to call this mask. Layer mask is a very convenient way to access the physics layers in your inspector, so we'll use that for this particular implementation. Now I am going to go to my same flock filter, and I'm going to copy and paste the code from this particular filter into our physics layer filter, because we're going to be using most of it the same way. Paste that in here. That also satisfies the fact that this is inheriting from context filter, because we are properly overriding it. And now what I'm going to do is I'm actually going to delete all of this inside of here, because we don't need the flock agent again in this case. What we're doing is we're checking against whether or not the particular transform is on the proper physics layer. So how we're going to do this is by using a process of bit shifting and using some logic gates. This is a little bit more advanced, but suffice it to say that this will get you a proper check of whether or not the object that you're looking at is on the same layer as your layer mask. So how this will work is we're going to do an if statement. This is ultimately going to return a bool to us, which is going to be if mask, meaning the value of the layer mask, what things are checked in that mask, equals the mask, and this is called ORed with, which is basically saying if the thing in the mask and the thing on the other side of this OR statement are on the same layers, then it will be true. And so we're going to say 1 bit shift item.gameObject dot layer. If that is true, if this evaluates to true, then our item is on the same layer, or on one of the layers that our mask is checked off. And so we can say here filtered dot add item. And that's all it actually takes. With this in place now, what we can do is we can go back into Unity. We can go to our filter objects folder, create a new physics layer filter. I'm going to set this to the obstacle layer. In fact, what I might do is call this, rename this to specifically the obstacle layer filter. And then in our behavior objects, I'm going to duplicate the avoidance behavior, and I'm going to call this one avoid obstacles. And this is going to be specifically take that obstacle layer filter. So now, if with this behavior, instead of avoiding other things in your own flock, now it's going to be avoiding obstacles. Lastly, I'm going to take the centered flock behavior that we are using for both our flocks, and I'm actually going to duplicate this, and I'm going to call this one orange flock behavior, because I want the orange agents to avoid the obstacle while the blue ones will not, so we can actually compare their behaviors. And so with orange flock behavior, I'm going to add a new behavior here, and that behavior will be to avoid obstacles, and I'll give it a pretty strong, maybe about a 5 weight, so that's going to actually impact and make, really change their trajectory when they encounter obstacles. And lastly, I'm just going to make sure that my flock orange here is using the orange flock behavior. So now, I'll zoom out on this a little bit so we can see in both views here, and we'll hit play. And that does not seem to be working. So let's see where we have something missing. Orange flock behavior has avoid obstacles. Avoid obstacles is on the layer filter. Filter is obstacle. These are all on the obstacle layer. Oh. The one problem is that none of our actual obstacles have colliders on them, so they're not actually being detected by the initial neighbor detection. So what we'll do is we'll select all of these at once, add component, circle collider, and with that in place, now they will actually be detected. So now when we hit play, we see that the orange, if they get around to it here, let's see, that group, there we go, this group here splits off into 2 directions because it's hit that collider, whereas the blue agents fly right over it. And so that is what we're looking for there. Now there is one limitation of this right now, which is that these are really based on both the range of the avoidance radius that the agents have, as well as it's limited to it's the points of these particular objects rather than it being the full kind of area of them. And so those are things that you could certainly expand upon and build upon in this. But for right now, we've got these additional functionalities working in our flock, so they move a little bit smarter, they're a little bit more modular and expandable. And hopefully you'll be able to use stuff like this in your game designs to have some cool effects or just have an interesting way of your AI working. So in the meantime, like and subscribe if you want to see more videos. I'll have a new video series out soon. Consider supporting on Patreon if you want to support more series like these. Thanks as always for watching, and I'll see you next time.